Alright, so now we're going to start talking about derivatives. Now, where does that word come from? Well, remember we've been using this. The limit as h goes to 0 of f of x plus h minus f of x all over h to be the slope of the tangent line. At x, f of x. The problem becomes, that's, as you saw in the last video, that's a lot of work. So we want some way to make this simpler. First, we're going to change this to the word derivative. And we're going to change this to rules. Alright, first here's some symbols for derivatives. We have y prime, f prime of x, dy dx, df dx. Alright, so those are some of the symbols for derivatives. So I'll be using a couple of these throughout the video. Now the good thing with rules is that do it once and never have to do it again. Alright, so like I said, this is one function derivatives. So that means we're going to work with f of x equals x. F of x equals a constant. F of x equals x plus a constant. F of x equals a constant times x. And finally in this one we're going to do f of x equals x to the n. Alright, I'll be adding a couple more videos to this for other rules, like adding two functions, subtracting two functions, multiplying, so on and so forth. But for this first one, we'll just stick with these. Alright, so let's start with that f of x equals x. What's f prime of x? Well, we know that's going to be the limit as h goes to 0 of f of x plus h minus f of x over h. So in this case we have f of x equals x, so f of x plus h is just x plus h. F of x is x all over h. And this is still as h goes to 0. What does that give us? Well, these cancel out. I'm left with h over h. And that gives me 1. So f prime of x in this case is just 1. Real easy. Alright. What about when it's a constant? So what I mean by that is like y equals 6. Well, we're going to do the same thing. Limit as h goes to 0, f of x plus h minus f of x all over h. In this case, that's going to be, well, no matter what I put in for x here, I always get the same constant out. So it's going to be constant minus a constant over h, which is going to be 0. So here, f prime of x equals 0. What about when it's f of x equals x plus a constant? F prime of x. Well, I do the same thing. I'm hoping people are realizing that this is why we have these rules, is because doing the workout is repetitious, and it just speeds up the process. So I don't have to do this every single time I go to take the derivative of something like this, because I know it's going to work. So what do we get? Well, it's going to be x plus h plus c minus x plus c all over h. I distribute the negative, I get x plus h plus c minus x minus c all over h. That's gone. That's gone. I get 1. Now, what's important about this? Well, where did I just see that one was a derivative? Well, it's just the it's f prime when f of x equals x. That idea is going to come in handy in the next video when we do the addition and subtraction rules. So just kind of keep that in your head for the next one. And this should make sense, by the way, because when you add a number, when you have the line y equals x, and you're adding something to it, you're not changing how fast the x is, you're not changing the slope of the function, you're just shifting it up or down the graph. What does change is when we have f of x equals a constant times x. So what's f prime of x in this case? Well, we do our definition here. So h goes to 0. 4, let's see, if I put x plus h in there, the c will be distributed just to speed things up. I'll get cx plus ch minus cx all over h. All those cancel out. That'll cancel out there then. I'm left with c. So that's my derivative, which is also the constant times f prime of the function, i.e. it's a constant times 1. So just a nice little note here to make for that to make sense. When a constant is multiplying a function, so like the cx, its derivative is the constant multiplied by the derivative of the function. I wasn't going to give many examples, but I do want to give a quick one for this. Let's say f of x is 5 times x plus 2. F prime of x is the same thing as 5 times f prime of x plus 2, which is 5 times, well, x plus 2, based off of this, is just 1, which is 5. Alright, so that's what I mean. You can just find the derivative of the function and multiply it by the constant. The last rule I want to go over for this video is what we call the power rule. Alright? That's an important term for you to know. It's when f of x is just x raised to some exponent. We'll call n. So we're going to do our due diligence here. Limit h goes to 0. F of x plus h minus f of x all over h. So this would be x plus h to the n power. Minus x to the n all over h. Now this is binomial expansion, which you should have done in algebra or pre-calc. So I'm not going to go over how you get that. I'll just go over what you end up with. X to the n plus n minus 1. Plus n times x to the n minus 1. I can read my own handwriting on here. Times h plus a constant, which we'll call c1, x to the n minus 2, h to the second, plus another constant, x to the n minus 3, h to the third, and that keeps going until we have n times x, the h times h to the n minus 1, plus h to the n minus 1, plus h to the n, sorry, minus x to the n. This is that one there. I'm not adding anything to that binomial. All over h. Well, the only thing that's canceling out here is these. When this h goes to 0, of, and this will look a lot cleaner down here, nx to the n minus 1 times h, plus another, plus constant 1 times x to the n minus 2, h to the second, plus constant 2, x to the n minus 3, h to the third, dot dot dot, n x to the h times h to the n minus 1, plus h to the n, all over h. Looks like a nightmare, doesn't it? However, you can reduce everything by 1h. So, we end up with n times x to the n minus 1 plus constant 1, x to the n minus 1 h, plus constant 2, x to the n minus 3, or n minus 2, minus 3, h to the second, n x, h to the n minus 2, plus h to the n minus 1. All over h. Those cancel out. And when I put 0 in for all those h's, this goes to 0. This goes to 0. Everything goes to 0 except n x to the n minus 1. And this is our derivative. So that's the first big rule we've covered. And like I said, in the next couple videos, I just want to break these up for time's sake. I'll do addition, subtraction, multiplication, we'll do division, and we'll do chain rule, which is for composite functions. Alright, so I will see you in the next video.